Hello everybody. So now in this particular video we'll be going through problem number 4 in your notebook. This is a different type of problem. So as we went through the concept of friction in the previous videos, we'll apply the same to solve the numerical. Let me just go through the problem. Here you have two bodies which are in contact with each other. So let me just read out the problem. A block weighing 4,500 Newton, this block, lower block, a block weighing 4,500 Newton is resting on a horizontal surface. This is the surface, horizontal surface as shown in the figure. Supports another block of 3,000 Newton weight. This is the upper block. So lower block of 4,500 Newton weight supports another block of 3,000 Newton as shown in the figure. So find the horizontal force P required to move the lower block to the left hand side. This force is to be found. So this is the external force which is required to move the lower block to the left hand side. Horizontally to the left. So upper block rests on the lower block and lower block rests on the horizontal surface. This is the given arrangement, and mu is given as 0.3. This is all about the given arrangement. Now let us just concentrate on the problem. What do we need? Ultimately we need the value of P. This horizontal force P is to be found. P is the horizontal force which is required to move the lower block to the left hand side. Now lower block rests on the horizontal surface. What about the upper block? Upper block rests on the lower block and it is connected to this vertical surface. It is in contact with the vertical surface. It is connected to the vertical surface with the help of this string or cable. The upper block is connected to the vertical surface. It is not in direct contact with the vertical surface, but still it is being connected to the vertical surface with the help of this string. It is tied to the vertical surface with the help of string. So it is not in direct contact with the vertical surface, whereas the lower block is in direct contact with the horizontal surface. So basically we need the value of P, and you have two bodies which are in contact with each other. So whenever you have two bodies which are in contact with each other, you have to draw an imaginary surface between both the bodies, because there is a movement between both the bodies. Here the upper body will be stationary because it is tied with the help of a string to the vertical surface, whereas lower body moves, is it not? So there is a friction between the bodies. There is a friction which is being developed, a friction resistance which is being developed between the bodies, because both the bodies are in contact with each other. However, there will be a friction resistance developed here, or the surface will offer a friction resistance because the lower body moves over the surface, or it's in contact with the surface. But this lower body is in contact with the upper body as well, or both the bodies are in contact with each other, and the lower body moves over the upper body as well. So there is a friction resistance between these two bodies whenever two bodies are in contact with each other. So when you have two bodies which are in contact with each other in any of the problems, you have to draw an imaginary surface between both the bodies. So this is the upper body and this is the lower body. I'll draw an imaginary horizontal surface in this way. So I've drawn an imaginary surface between both the bodies, and let me name the imaginary surface as surface number 2, and let this horizontal surface be surface number 1. No need to mark the vertical surface because vertical surface is nowhere in direct contact with the bodies. Surface number 2 is the imaginary surface, and surface number 1 is the horizontal given surface. So let us just to differentiate the surfaces, because we have two surfaces here. This is the imaginary surface which we have drawn, which is surface number 2. So whenever you have two bodies which are in contact with each other, the first and foremost thing which you're supposed to do is to draw an imaginary surface between both the bodies. So once you draw an imaginary surface between both the bodies, you have to consider both the bodies separately. Along with the imaginary surface. along with the imaginary surface. Whereas when you consider the upper body, you have to consider the upper body and the imaginary surface. When you consider the lower body, you have to consider lower body along with the imaginary surface and the horizontal surface. Or basically, you have to consider both the bodies separately now. So once you draw an imaginary surface between both the bodies, you have to consider both the bodies separately and analyze along with the imaginary surface. Imaginary surface should be common for both the bodies. So now, since you have two bodies, let us consider both the bodies separately. Both the bodies separately. Let me consider the upper body now. Let me consider the upper body of 3000 Newton self-weight along with the imaginary surface. Let me draw the upper body in this way. This is the upper body. And this is the imaginary surface, surface number 2. I'll mark it as surface number 2. This is the imaginary surface which we have drawn. I'm just reproducing the same thing here. And this is being connected to the vertical surface in this vertical surface axial. I'll just draw a small part of vertical surface. And this angle is 30 degrees. This angle is 30 degrees. Done. Now we have to follow the same procedure as we did for the previous problems. Step number 1 is to draw the coordinates. Step number 1 is to draw the coordinates. How to draw the coordinates? You are supposed to draw the coordinates in such a way that the x-axis should always be parallel to the surface. Surface is the imaginary surface. So this will be the x-axis and this will be the y-axis. X and y-axis. Done. We have drawn the coordinates now. So after drawing the coordinates, you have to mark the self-weight. Self-weight will always move vertically downwards. Self-weight is given as 3000 newtons. Self-weight is given as 3000 newtons. Yeah. The self-weight will always act vertically downwards. So we have marked the self-weight. So what after marking the self-weight, we have to mark the normal reaction. We have to mark the normal reaction. Normal reaction will be offered by the surface which is in contact with the body. Vertical surface is not in contact with the body, but the imaginary surface, what you have, surface number 2, is in contact with the body. So this imaginary surface will offer a normal reaction on the body. Normal reaction will always act in this way. I'll mark normal reaction here. Normal reaction will be directed towards the body and it will be perpendicular to the surface. And let me write or indicate it as N2, normal reaction offered by the second surface. N, normal reaction offered by the second surface. Now, the important aspect, you have to mark the friction resistance. Frictional resistance. To mark the frictional resistance, everybody, observe here. So this is the upper body that we have considered. This is the upper body, what we have considered. Is it? Upper body is connected to the vertical surface. As you can see here in the question, it is being connected to the vertical surface with the help of a string. So whenever you have a string, as we went through the concept of string in equilibrium, when you mark a tension along the string, tension will always move away from the body. Tension will always move away from the body as far as string is concerned. So when you have a string given in the problem, tension will always move away from the body. Tension along the string. This is the string which connects the upper body to the vertical surface. So tension along the string will always move away from the body. There will be a tension. Whenever you have string, there will be some force which runs through the body. Will be moving away from the body and it will hold the body, or it will try to pull the body towards the vertical surface. It will try to hold the body and pull the body towards the vertical surface, So this angle is 30 degrees. Angle is 30 degrees. Hope this is clear. So if you have a tension, tension will always move away from the body. This is the body. Tension will always move away from the body. And because of this tension, it tries to pull the body towards the vertical surface. So when the body is being pulled or pushed towards the vertical surface, its trend of motion is in this way. Is it not? Its trend of motion is this way. So when body moves in this direction, frictional resistance should be acting in direction opposite to that. Friction resistance should be acting in a direction opposite to it. Body should move in this direction because this tension will not allow the body to move in the other direction. Tension will not allow the body. Tension always moves away from the body, or it tries to pull the body towards the vertical surface. So trend of motion of this particular body is towards the vertical surface. It tries to pull the body towards the vertical surface. So trend of motion is towards the vertical surface, the direction of friction resistance should be away from the vertical surface. In this way, I'll mark the friction resistance here. It should be tangential to the surface, whereas normal reaction will be perpendicular to the surface. Friction resistance F2, let me mark it as F2. F2 should be tangential to the surface. F2 can be written as mu into N2. Mu into N2. F2 can be written as mu into N2. So we have marked all the forces now. Step number 5. 4 is also done. We have to go to step number 5, wherein you reproduce only the coordinates along with the forces. Let me reproduce it to draw the free body diagram. Reproduce all the forces. Tension T can be drawn here. Tension T, which makes an angle of 30 degrees. Now this is x-axis. This is y-axis. N2 can be drawn here. N2 can be drawn here. Right? 3000 Newton can be drawn here. 3000 can be drawn here. And F2 can be drawn. F2, which is equal to mu into N2. So this is the free body diagram. This is the free body diagram. Now we have completed step to draw free body diagram as well. Once you draw the free body diagram, the only way is to apply the conditions of equilibrium. Now we are considering only the upper body along with the imaginary surface. The same process is to be followed with the lower body as well. Done. So let us apply the conditions of equilibrium. The first condition is summation of Fx equal to 0. Summation of Fx equal to 0 will be the first condition. So when you apply summation of Fx equal to 0, list down all the force which moves in x direction. It will be minus F2 because it moves horizontal to the left, and resolve this force into its horizontal and vertical components. Horizontal component will be T cos 30 and the vertical component will be T sin 30. So it is minus F2 plus T cos 30 is equal to 0. So let us simplify this. F2 can be written in this way: minus mu into N2 plus T cos 30 is equal to 0. Now we can simplify cos 30 and write it as 0.86. So we know the value of mu as 0.8. Substitute this as well. So minus 0.3 into N2 plus T into cos 30 is 0.86 is equal to 0. Let us simplify this further. Let me take this to the other side. And finally, let me write it in this way. 0.86 T is equal to 0.3 into N. 0.3 into N. Let this be equation number 1. Done. Now let us apply the second condition of equilibrium, which is summation of Fy equal to 0. Summation of Fy equal to 0. List down all the forces which moves in y direction. So which is minus 3000 plus N2 minus 3000 plus N2 plus T sin 30. T sin 30 is equal to 0. I can express this, I can rearrange and I can express this in terms of N2, or I can write N2 is equal to, just by keeping N2 in the left hand side, I'll bring everything to the right hand side. N2 will be equal to 3000 plus 3000 minus T into sin 30. Sin 30 with 30 can be written as 0.5. So T into 0.5 into. So this is N2. N2 is 3000 minus T into 0.5. So let this be equation number 2. I'll mark this as equation number 2. Now we have two equations, equation 1 and equation 2. Let me rub this. Now we have two equations, equation 1 and equation 2. So what is to be done now when you have two equations? You can substitute equation 2 in equation 1. Equation 2 in equation 1. 2 is N2 is equal to 3000 minus T into 0.5 can be substituted in equation 1. So equation 1 will be 0.86 T is equal to 0.3 into N2 will be, I'll rub this as well. I just need the equation. I'll rub this. Point 3 into N2 is 3000 minus T into 0.5. This is equation 1 by substituting N2 as 3000 minus. So T is the only unknown here. You can easily find the value of T. And T will be 885.8. 885.8 newtons. T will be 885. So once you get the value of T, you can substitute the value of T in equation 2. T in equation 2 to get the value of N2. To get the value of N2. Direct substitution it is. So if you substitute, you'll get the value of N2 as 2557.1. 2557.1 newtons. So this will be the value of N2. This will be the value of N2. Let me write all the values here. N2 will be 2557.1 newtons and T is 885.8 newtons. These are the calculated values by considering the upper body, along with the imaginary surface. So similarly, ultimately we need the value of P. I'm reminding this again. Ultimately, we need the value of P. So we have done all the calculations as far as the upper body is concerned. So once you get the value of N2, you can find the value of F2 as well. F2 is nothing but it's mu into N2. Mu is 0.3 into N2 will give you the value of F3. We don't need that. Once you find the value of normal reaction, if you know the coefficient of friction, you can straight away multiply it and find the friction resistance. So we have considered the upper body along with the imaginary surface and we found the tension and the N2, normal reaction offered by the imaginary surface. Now let us consider the lower body. Along with the imaginary surface. So lower body goes in this way. I'll draw the lower body. This is the lower body and this is force P. Now lower body is being sandwiched between two surfaces. This is the horizontal surface, or we have marked this surface as surface number 1, and this is the imaginary surface what we have drawn, which is surface number 2, imaginary surface number 2. And this is the external force what we need. So this is the lower body. Now let us follow the same steps. For this particular problem as well. So when we follow the same steps, step number 1 is to draw the coordinates such that x-axis should always be parallel to the surface. This will be x-axis. This is y. So once you draw the x-axis, you have to mark the self-weight. Self-weight will be acting vertically downwards. Mark the self-weight. Self-weight is 4,500 newtons. 4,500. Done. Now we have to mark the normal reaction. You have to mark the self-weight. You have to mark the normal reaction. See, normal reaction will be offered by both the surfaces here because the lower body is sandwiched between two surfaces. The upper surface is the imaginary surface and the lower surface is the given horizontal surface. Surface number 2 and surface number 1. Both the surfaces will offer normal reaction. Let me mark the normal reaction offered by surface number 2. So normal reaction offered by, I'll mark it here. Normal reaction offered by surface number 2. Then write the self-weight here. This will be self-weight, 4,500 newtons. So I'll mark the normal reaction offered by surface number 2 here as N2. We know the value of N2. It is 2557. N2 is 2557.1 newtons. Normal reaction will be directed towards the body and it is perpendicular to the surface. I hope you know how to mark normal reaction. Let me mark the normal reaction offered by surface number 1. Normal reaction offered by surface number 1 can be drawn in this way. It will be directed towards the body and I'll mark it as N1 and it will be perpendicular to the surface. We don't know the value of N1. Whereas we know the value of N2. We got it from the previous calculation. So we have marked the normal reaction. There is no string available here. There is no string in this arrangement. Now, the body moves horizontally to the left. Now it's time to mark the friction resistance, which is very important. Here the body moves horizontally to the left. When body moves horizontally to the left, friction resistance will be acting horizontally to the right. And both the surfaces will offer friction resistance because this lower body is in contact with the upper surface as well as the lower surface. Try to understand. Friction resistance will be offered by both the surfaces here, the upper surface, imaginary surface as well as the given surface. So when you move this lower body horizontally to the left hand side, the friction resistance offered by the lower surface will be acting horizontally to the right and it should be tangential to the surface. Let me mark this as F1, which is equal to mu into N1. Similarly, friction resistance offered by the imaginary surface will also be acting opposite to the direction of motion of the body. Body moves horizontally to the left, so friction resistance will be acting horizontally to the right. Let me mark this as F2, which is mu into N2. We know the value of N2 and mu. So basically, we know the value of F2 completely. We know the value of mu as 0.3. So we have marked all the forces now. We have marked all the forces and we have to draw the free body diagram of this particular object. This is the second body. So when I draw the free body diagram, let me draw the free body diagram here. Let this be x-axis. Let this be the weight. Let me reproduce only the forces. I'll draw the self weight here. Let this be 4,500 newtons. I'll draw the self weight here. Let this be 4,500 newtons. And let me mark N2 as well. I'll mark N2 here. N2 is equal to 2,557.1 meters. Done. And let me mark N1 here. Let this be N1. We don't know the value of N1. Let this be P. Let this be P. And you have F1 and F2. F1 can be marked here and F2 can be marked here. F1 is mu into N1. I'll not write it here. F1 is mu into N1 and F2 is mu into N2. In the calculation, let us show the values. These are the forces. These are the forces. This is the free body diagram. These are the forces acting on the lower body. Now, let us, once we draw the free body diagram, we have to apply the conditions of equilibrium. Once we draw the free body diagram, this is the free body diagram available. We have to apply the conditions of equilibrium. The first condition of equilibrium is summation of Fx equal to 0. Summation of Fx equal to 0. How many forces we have which moves in x direction? It is minus P plus F1 plus F2 is equal to 0. Let us simplify this. Minus P. F1 is mu into N1 plus F2 is mu is 0.3. Even here mu is 0.3 into N2 is 2,557.1 is equal to 0. Even here mu is 0.3. Right. So this is equation. Let me consider this as equation number 1 here, as far as the second step is concerned. Done. Now let me apply the second condition of equilibrium. No need to apply. No need to consider this as equation number 1. We can straight away find the value of N1 here because N1 is the only unknown. Let us find it here. So minus, let me just write it as minus P. Let me simplify and write it. We have to consider this as equation 1. Minus P plus 0.3 N1 plus 0.3 into 2,557.1 is equal to 0. Let me consider this as equation number 1. We cannot solve this. We have two unknowns. N1 and this is N1 and P. Both are unknown. So let me consider this as equation number 1. Now apply the second condition of equilibrium, which is summation of Fy equal to 0. Summation of Fy equal to 0. How many forces do we have which moves in y direction? We have minus 4,500 minus 2,557.1, which is N2 plus N1 is equal to 0. So we can straight away find the value of N1 here. N1 is 7,057.1. So once we get the value of N1, we have to substitute the value of N1 in equation. We have to substitute the value of N1 in equation 1. N1 in equation 1 to get the value of P. Equation 1 is this. So this is N1. Substitute this as 7,057.1 to get the value of P, and finally the value of P will be 2,884. 2,884.2 newtons. So this is how you solve when you have two bodies. When you have two bodies which are in contact with each other. You have to draw an imaginary surface between both the bodies. Consider both the surfaces separately and consider both the bodies separately along with the imaginary surface. And solve it. So if you have any doubts, you can contact me anytime as far as this particular problem is concerned. So by this we complete the problems of normal friction with the single body and double bodies. So in the next video, we'll be going through the problems related to wedge friction. Thank you.